Here you can see an example of how you can create a Verilog A text view from the schematic. You can specify Verilog A in the toView name. This name could be different to what matters is the data type, which is set to Verilog A editor. You can check the option to display cell view to see the contents of the Verilog text in the text editor. When you click OK, it opens the Verilog A text editor, wherein you can see the module and pin definitions. So now that the text is defined and the Verilog A cell view is created, you can create its symbol using the automatic symbol generator. Here you can see that the from view name is set to Verilog A and the to view name is set to symbol, and the data type now is set to schematic symbol. You can click OK and this brings up the symbol generation options form. Your pins will be defined based on your text definition in your Verilog A code, and you need to ensure that you choose the type of template you want for your symbol, and then you can click on OK. By using hierarchical net listing in AD, you can place symbols containing Verilog A module descriptions directly into schematics. The netlister includes the path to the module description in the final netlist with an AHDL_include statement. If the design is structured in multiple levels, components with Verilog A views can be included below a schematic level, and components with schematic views can be included below Verilog A components. A Verilog A module cannot be added to a schematic without a corresponding symbol view. See the symbol view here. If you open it or descend its hierarchy, you can see the corresponding Verilog A definition. Now you can convert structural Verilog netlist in the Virtuoso environment. You can use the Verilog in translator to convert them to Virtuoso schematics and symbols, a netlist in Cadence open access format, or Verilog text views in a Cadence format library. Let's look at how you can import a structural Verilog definition and create a schematic and corresponding symbol in the Virtuoso environment. You can do this using the Verilog in form. You can access this form by going to the CIW and choosing File Import and then Verilog. On this and the next few slides, we discuss the setup for this form. You are currently seeing the top portion of this form and you're looking at the Import Options tab. We cannot go over every option in the form, but we shall talk about the relevant ones. To set up this portion, specify the Verilog files to import along with its actual location. Also specify the target library and the reference library. You can specify any library extensions that are there, whether it's .v, .vlog, etc. And for structural modules, you can specify how you want to import the modules. Over here, it's set to be imported as a schematic, and you can choose which type of views you want to create. Here is the bottom portion of the Import Options tab, and here there are some more fields that you can populate for your setup. For instance, in the pre-compiled Verilog library option, you can specify list of pre-compiled Verilog libraries. The HDL view name field can be used to find the immediate representation. The target compile library name field specifies the intermediate representation view if you have one, and you can browse and select that view. If you check the box for compile Verilog library only option, you specify that you do not want to import anything. In the -F options, you can simultaneously enter command line options for imported files. In the -V option, you can specify the files needed to be compiled. And in the -Y options, you can specify the Verilog library file. In the Global Net Options tab, you can specify global nets for power and ground. Global signals are signals other than power and ground, and net expression that you specify translates tie highs and tie lows to use net expression values. The schematic generation tab is again long, and the snapshot is divided over 2 slides. Here you see the top portion of the form. In this tab, you can specify the pin placement, and you can choose on which side you want to place the pins. You can load from a pin placement file if you have everything set up in a separate file. And in the through cell view to be used for port short section, you can specify a component used between shorted ports. And in the continuous assignment symbol section, you can specify the path symbol to avoid net shorting. This is the continuation of the schematic generation options tab of the form. In the connect by name net section, you can specify nets that use names and not physical wires for connectivity. In the schematic dimension section, you can specify the dimensions of the schematic such as maximum number of rows, columns, font height of the text used in the schematic, and spacing between the components and the text used. In the sheet symbol section, you can specify none. This creates a single sheet, and do remember that spacings are in inches. Once everything is done and everything is set up, you can click OK on the Verilog in form. You will be able to see the log file. You can then go to the library manager and browse to the library and cell for which you were importing the Verilog definition. You can see the symbol and schematic views over there in the library manager, and you can double click to open the symbol view in the symbol editor. Similarly, you can double click and open the schematic in the schematic editor. Similar to the Verilog in option, you can use the Spice in option to import text-based HSpice, Spectre, Spice and CDL netlist into the Virtuoso environment and create either Virtuoso schematic or Virtuoso netlist views. You can do this to use these definitions in the Virtuoso analog design environment and in the Virtuoso layout suite. You have the option to modify or update the imported schematic representations before passing them on to other tools on the Virtuoso platform. You can have your Spice definition in a text format. Use the Spice front-end parser to generate the Virtuoso netlist view. You can use the inbuilt connectivity to schematic module to generate the Virtuoso schematic view. This and the next few slides discuss the setup of the Virtuoso Spice in form. Similar to the Verilog in form, you can choose File and Import and then Spice to open the Spice in form that you see on the screen. What you see here is the Input tab. Setup is over multiple tabs on this form, and in the Input tab you can specify the netlist file, you can specify the netlist language, you can specify any subcircuits list that you want to import. You can check the box for device mapping file, and the purpose of the device mapping file is to indicate the relationship of the Spice file device names to the device names in the destination library. You can specify the master cell for ground node. It specifies the cell that represents node 0. In the Output tab of this form, you can specify the output library, that's the library name to receive the new schematic or netlist. You can specify the output view type, whether it should be a netlist or schematic, and in the Save Device Simulation Information in CDF4 field, you can specify the parameters and term order that could be saved for a specific simulator. In this case, it is set to Spectre. In the Schematic Generation tab, you can specify the maximum number of rows, the maximum number of columns for device placement, the line-to-line spacing and the line-to-component spacing between elements. You can enable the Analog Schematic Generation checkbox to create an analog schematic. In the Device Map tab, in the Device to Map field, you can specify the primitive you want to map. In the Mapped to field, you can specify user-defined master cell name. In the Prop Match field, you can specify the properties of primitive to match into the user-defined cell. You can use the File button to create a new map file or open an existing map file. You can use the Add Above button to enable the Add and Edit fields. In the Override Cells tab, you can choose the library cells to be replaced by Spice in. In the Analog Schematic Generation tab, you can specify the cell views to be used for power and ground cells. You can enter global net names in the field that is provided, and you can click Save to save the values from all the tabs that are saved to a file for recall in subsequent Spice-in runs. And you can click Load to set the values in the tabs that have been saved previously. This recalls the values from the saved file. You can click OK in the Spice-in form if everything is set up correctly, and you will get a pop-up information about a successful import, and it will ask you if you want to view the log file. Go to the chosen library and the chosen cell in the library manager, and you can open the newly created schematic view.